Hello everyone, my name is Anand Suthar and welcome back to our LeetCode problem solving series. Today we are solving the swipe nodes in a pair, LeetCode problem number 24. This is linked list problem where we need to swipe the every two adjacent node. The trick is we need to swipe the actual nodes, not just their values. Let me show you how to solve this with a super clean recursive approach. Here is the problem. We are given a linked list and we need to swipe the every two adjacent nodes. Let me show you some example. In example 1, we have given an input 1, 2, 3, 4 and its output is 2, 1, 4, 3. We swipe 1 and 2, then we swipe 3 and 4. And similarly in example 2, we have given an input 1, 2, 3 and its output is 2, 1, 3. Here we have an odd number of nodes, so we swipe 1 and 2 and 3 stay as it is. We cannot just swap the values, we actually need to swap the nodes themselves by changing the next pointers. Let me explain the recursive approach. The recursive approach is very elegant. Here is the idea. In step 1, if the list is empty or has only one node, just return the head nothing to swipe. And in step 2, we have at least two nodes. Let's call them first and second. And in step 3, we need to swipe these two nodes. So after swiping, second should be a first. But what about the rest of the list? The part after these two nodes needs to swipe as well. So in step 4, we recursively swipe the rest of the linked link starting from the nodes after second. And in step 6, then we make the first point to this recursively swiped result. And in step 7, finally we make second pointer to the first. And in step 8, we return that second as the new head of the pair. Let me write the code. It's only 8 lines. We start inside our public function swipe pairs. Very first line is our base case. We check two conditions using a logical OR operator. If the head is empty, meaning the list has a 0 nodes, or if head next is empty, meaning there is only one lonely nodes left, there is absolutely nothing to swipe. We simply return the head exactly as it is and stop recursion. Now if we have at least two nodes, let's call them node 1 and node 2. Head is the pointing to node 1. We declare a new pointer called new heads and point it to the head next. This means the new head is now holding since node 2 will becomes the front of the pair. After the swiping, new head will elegantly be the nodes we return. This line is absolutely magic. Before we connect node 2 to node 1, we need to know what node 1 should point to next. It should not point to the node 2 anymore, it needs to point the rest of the modified list. So we make the recursive calls swipe pairs and pass it head next and next, which skips over the current pair and jumps straight to the node 3. We trust recursion to complete the fix and swipe the rest of the list for us. Whether the swiping sub list is written, we attach it directly to our current node, tails using the head next. Now that node 1 is safely connected to the remaining list, we finish our local swipe, we start the new head node 2 and point it to the next pointer back to the head node 1. Just like that, node 2 now points to node 1 and node 1 points to the rest of the list. This swipe is complete. Finally, we return the new head because the node 2 is not just an official new front row to set up this pair. The recursion wins. All this pair is seamlessly linked with the perfectly swapped chain. Because we process each pair of the node exactly once, for this time its complexity is on and our space complexity is on because of recursive call stack. Let me submit this. It passes that the swipe nodes in the pairing using recursion. Key points to remember. Base case handle the empty or the single nodes. Mark second nodes as a new head. Recursively swipe the rest. Connect first node to swipe the rest. Connect second node to first. Return the second node. If this helped you, please like and subscribe. I'm Anand. Thanks for watching. I'll see you in the next problem.